Some important things that you may have not known in C++ or programming in general. The first thing is pre versus post increment. So what is incrementation? So you guys are familiar with stuff like I++ and I minus. But there are also things like plus I and minus I. So what are these basically? These are called post and prefix incrementations. The two versions have different meanings. So for instance, this version is similar, but it has like this one's subtracting, this one's adding. Over here we have adding and subtracting, but they're actually different. They look similar, but they actually have different meanings. So here is the operand and this is the operator. The operand is before the operator. So when placed before the operand, so when the operators are placed before the operand, so these over here. So when operators are placed before the operand, they're called pre-increment and pre-decrement. These are called pre-increment and pre-decrement. So let me just write a comment here. I'll say pre. So they're called pre-increment and pre-decrement. In this case, the value that is stored in the variable of the operand is incremented or decremented first, and then the operand is returned. Here is post increment and post decrement. So we have here the pre-increment and pre-decrement first. So let's just go and first let's solve this out. So here we have an example. Suppose we have an integer x is equal to 10. Now what we want to do is we want to decrement this using our pre-decrement operator. When we do something like into, let's say we want to assign a new variable, so we want to initialize a variable into z, and we want to put that x, but we want to put minus before of it. First thing is that the x will be decremented to 9, and this is the first step that would happen. Once it's decremented to 9, it will be assigned to z. So z will have 9 as the answer. So over here we'll have 9. So if we print them out, let's say console output, and we say x value, and then we have the space, and then we have the z variable. So if we print this out, so let's just run the code, we'll get 9 and 9. Notice that they changed, because over here it's the pre-decrement operator, which will decrement the variable's value first to -1. So it's going to be 9, and then it will assign it to z. Since we have x, which is now 9, because it's decremented, and the z will be 9 as well. Now let's take a look at post increment or post decrement operator. Since post means past, right after it, so that means that they're going to be after the operand. Here, postfix operators require more than just prefix operator steps. First, a copy of the operand is made. So we have here a variable, and we say as x is equal to 10. So I have it 10. And then what we could do here is we could assign our new variable, which is y, and assign the postfix operation, which is x minus to it. And then we could console output our variable for console output, and we have x, and then we have a space here, and then we have the variable of y. So what do you think will be appearing here? We have 10, which is x, pretty cool. Now this is a postfix operator. The thing is that there are a sequence of steps to understand. The first of the steps is that a copy of the operand is made. Since we have this operand as x, so a copy of this is made, which is x is equal to 10. This is going to be stored somewhere, so we'll say x is equal to 10. So basically it's decremented to 9. Right after that, a copy of this is made, and then it's decremented right after that. So finally the copy, which was x is equal to 10, is going to be assigned to y, and x will be decremented after that because it's in the post operation. So we'll have y as 10, and we'll have x as the value 9 because it's decremented afterwards. So it's a little bit tricky, but you'll understand if you watch the video very carefully and understand what the steps were. So let's just run this up. And over here you can see 9, which is the value of x, and 10, which is the value of y. So the next thing I wanted to talk about were assignment operators. Assignment operators are used to assign values to variables. For instance, if we have a variable x and we assign it to a value 5, this means that we assigned it using an assignment operator. Now, compound assignment operators can perform arithmetic operations on a variable and reassign its value in one step. Now, this one-step operation could be called as a shorthand operator. So what we could do here is x plus equals to, so we have x plus equals to, and we can have anything like 5. So what this does is that it adds 5 to the existing value of x. The existing value of x is 5, so it adds 5 to it. It's same like this thing over here. So we have x is equal to x, and we have plus y 5. So it's much shorter, and it's also known as a shorthand operator. Not only that, but we can substitute almost any operator using this compound assignment. So compound assignment has these like x, and we could have multiplied equals to, and we could have 2. Multiply the existing value of x by 2. And in this case, it would be x is equal to x multiplied by 2. So over here, you'd see that it would be 5, it would be 10. After that, it would be 10 multiplied by 2, which is 20. So if we get the value of x over here, it's supposed to give us 20. So let's give a console output, and we're going to say value of x. So it should give us 20. So let's just run the code. And here we got 20. Cool. Another thing that I wanted to bring up was bitwise operators. So bitwise operators are used to manipulate variables at the bit level. Now bit level means like those bits that are in 1 byte there's 8 bits. So those things are what I'm talking about. So bit level, like this stuff. Bitwise operators are most commonly used with numerical variables to perform bit operations. And there are 6 bitwise operators in C++. And these are the 6 bitwise operators. Alright, so let's just understand what this is talking about. We have 6 different bitwise operators. The first one is these 2 less than signs. They look like 2 insertion operators. These 2 greater than signs, they look like 2 extraction operators. This tilde, this ampersand, a pipe, and then there's a caret. So over here we have this left shift, which is you could see that it's going towards the right, so it's called left shift. And then you could have here's an example of left shift bits in x left by y, and we have right shift, and it has this going in the which is going in the left side. You'd see that's facing to the left side, so this is called right shift, and it's shift bits in x right by y. And then we have tilde, bitwise not, and then we have, it's like a negation, so flip all bits in x, it looks like a negation. And then we have an ampersand, bitwise and, so we have x and y, so bitwise and. So this is going to be we're going to be understanding how this is going to work too, because you know, like in and logical operators, when 2 things are true, then it's true. Else if it's like 1 true and 1 is false, then it's false. Or both things have to be true in order for this AND operator to be true. And then there's OR, using this pipe, so bitwise OR. And in this case we have one thing, at least one thing has to be true, and if the other thing is false, then it's still according to that it's true. But if both are false, then it's false. So we have this caret, bitwise exclusive OR, so meaning that whatever is OR, and it's gonna give the exclusive OR touch to this. This could be understood through exclusive OR and exclusive NOR gates, logical gates. So the first example we're gonna be taking is the left shift, which is the first one. And this is left shift. And the left shift is basically 2 insertion operators that are going towards the right side, but they're called left shift. Now, what we could have here is that this thing before, this over here, would have some kind of variable, and would have some kind of variable or number here. N is some kind of variable, and over here N is defined as, let's say, 32. Now, N will be left shifted, and the second operator decides the number of places to shift. So suppose we have 2 over here. Means we're shifting this by 2. So according to this, we could read this as similar to like this. So we'd have n is equal to n, and then would have it multiplied. So we could have this asterisk symbol, and would be 2 the raised to the power, so exponent here, and then we'd have the portion which is 2. So this is how the formula goes. So if we have x left shift of y can equal to x equals to x, and then it multiplies with the 2 raised to the power, so 2 raised to the power of y. So if this is y, so it's going to be multiplying raised to the power to this. So we have 2, which is the general, and then we have the number which was after that, which is 2. So we're going to put 2 over here. And then before that we have n, which is x. So x is over here, n was here, so that's that, and then this is our new value for n, implementing this. So n was 32, we put 32 inside, asterisk, and then we have 2, and we have to the power, so to the power of 2. 2 to the power of 2 is 4, so 32 multiplied by 4 will equal to 88, so we could have 88 over here. So this is our new value for n. So let's take an example of a left shift operator. Int x is equal to 3. Now let's have int y is equal to something like 9. Now what we want to do is we want to say int z, so z is equal to x, and we have this left shift operator. So we can say this, and we have 2. So what is this going to mean? So we have x. Over here, x is 3. 2 meaning that decides the number of places to shift. In this case, we have to shift 2 places. So z equals 12 in this case. So it would equal to 12. And in bits, it would look like the numbers this. But before that, let's look at what 3 means in binary. So 3 means like this. 9 means this. So, and when we're talking about this left shift, it would be this, which is 12. This is the left binary for that. But the thing is that how is this done? Let's remember that formula. So that formula was something like this. It was like x is equal to, so the value of x is equal to x. And then we had the multiplied with the 2, and then we had an exponent. So we'd have an exponent, and would have the number which is afterwards, so y. So in this case, we'd have in x portion would have the 3, and over here we have 2, and then would have the number which is after that, which is 2. So in this case, it would be 4, and now 4, 8, 12. So this equals to 12. Now 12 in binary means 1100. So let's just have z console output. So let's have this printed in our terminal screen. So error z was not declared in this scope. The problem here is that these had to be commented. So it wasn't giving me the right. Now I understand. Now it should work. So if I like run through here, it should work. Yeah, there you go. 12 is over here. Pretty cool. So that's what we wanted. 12 in binary, which is this, but it appeared in the decimal formation. The right shift operator isn't that different. It's just a representative using these 2 greater than signs, which is pointing towards the left side. And we could have an example similar to the one we had for left shift. So in right shift, we have, suppose we have x and y. This is equal to something as x is equal to x, and we have that divided by, not multiplied now. So we have x divided by 2, and we have raised to the power of the y. So this is how it's going to be implemented. Suppose we have let's say a value of n is equal to, say, n is equal to 32. So if n is equal to 32 here, we'll have to put the value. So if we want a shift over here, so we'd say n, and we'd say right shift, and we want n right shifted with 2 as the number. So what we could do here is it's going to be n, so let's just have it implies, and we'd say n is equal to n, and then we'd have it divided, so we'd have it divided by 2, and then we have the exponent here, and then exponent after that is the 2. So over here would be 2 raised to the power of 2, and 2 raised to the power of 2 is pretty simple, is 4. So we could write 4 instead of that. And for n, we have 32. So we could say 32. Divided by 4, simply 8 So this is going to be our answer. So for instance, let's say we have the same variable. So int x is equal to 3. And we have int y is equal to 9. And then we have, let's say, z. So we'd have int z. And then we have that equal to y, which is the first one. And then we'd have this right shift operator with 1. Now let's see roughly what would happen. Over here we have y, which is the value of 9. So it would be dividing with 2 raised to the power of the second value, which is after the right shift operator. This one. So we gotta just apply that over here. So we have 2 raised to the power of 1, which is over here instead of y. And 2 raised to the power of 1, which is simply 2. And 9 divided by 2. So 9 divided by 2 will be 4.5. But in case of integer division that we're dealing with, it's just going to be 4. And 4 in binary is simple as this. So this is 1, 2, 4, and then we have 8. So this is 4 in binary. So 4 should appear as our answer. Let's just run this code. So let's have a console output. And let's have the value of z, semicolon here. And let's just run. So over here we have 4. Awesome. So the other 4 bitwise operators are pretty easy and simple. The one that we have is tilde, and this is basically a negation, and it's called a bitwise not. So for instance, if we have a binary number like this, now 1010 means 10 in decimal. So this is binary. It's just gonna flip or toggle the values. Over here we have 1 is gonna be 0, then 0 will be 1, the 1 will be 0 now, and then the 0 will be 1. So it's just gonna be toggling it out, and this is now 1, 2, 4. So we have 5 as the value over here. So this is just the toggled value. After that, we have the value of ampersand, which is another bitwise operator. So the bitwise operator of ampersand is pretty simple. Suppose we have a number like say 1, 0, 0, and over here on the bottom portion, let's say we have 0, 0, 1, 1. In AND operators, it's like this. Both of them have to be true in order for the condition to be true. If one is false and the other is true, it would be always false. And if both are false, then it's definitely false. So over here we have one condition true and the other condition as false. So definitely this is 0, which is false. Over here, this is another condition that is true and false, so it's false. And then we have over here, which is false as well. And over here is false as well. So this is what it's going to be replied. So this is the bitwise AND operator for these two numbers, which are above here. So these two numbers, bitwise AND is this 0. If we talk about the bitwise OR, which is denoted using this pipe symbol, that's if one of the conditions are true and the other condition is false, then it's true. If both are true, then it's definitely true. And if both are false, then it's obviously false. So over here we have this as true because 1 is true. This is true because 1 is true. This is true, which is 1 is true. And over here, which is true. And so this is the number after all of the operations of this bitwise OR. So now let's talk about the bitwise XOR or exclusive OR. And this is represented using this caret symbol. And what it does is that it does an exclusive OR operation. So now let's go and check the truth table for the exclusive OR operation. Here we're on electrical4u.com, and over here I could see that there is this truth table which has 0011, and then B is 0101, and then the X output is 0 in case of both are 0, and then we have this should be 1 and this is 1, and then this should be 1 and this is 1, but in case of both are true, this is 0. And the reason for this is that it's exclusive OR and it's not simple OR. OR simple would be 0111, but in case of exclusive OR, it's 0110, because exclusiveness means like if one is true and the other is false, then it's true exclusively, and it's 0 and then 1 is true and 1 is false, then it's exclusively, so it means 1. And in case of them being same or same inputs, like same false, so it's 0, and if it's same true, then it's 0. That's how I learned it. So now let's talk about null pointers. Now let's talk about null pointers in C++. So if you guys haven't watched my video of pointers and references, then go check that video out. There will be a card on the top right corner of the screen, so check that video out and then come to this video. It's dangerous to leave a pointer variable uninitialized. So if I'm talking about uninitialized, here we have a pointer. We have pointer to int. So we say ptr. Now I have to give a reference variable to this. Suppose we have some address of, and we have a name, and now we have that name defined before. So it should have a string, so let's say string name. And so we're supposed to have that name defined over here, let's say coding cleverly. We have this coding cleverly reserved inside the computer memory, and it has some kind of address which we could use to locate it. So we use that address of operator to get the address of this name variable inside the computer memory, and we stored it into this variable called PTR. And this is basically the asterisk operator, and this is referred to as pointer to int of PTR. So that's what it's referred to. Now, what null pointers are is that if I keep a variable uninitialized, suppose that we have just this. Now this is actually a dangerous practice. Right here, we have nothing initialized to this. We don't have a value specified. If you are unsure where to point, you don't know where to point, because I was pointing to a name variable which was inside of my memory, but now I'm unsure where to point. What we have to do is assign the variable to null pointer, and we have to do is basically assign using equal, and then we have nullptr, and we have to do semicolon. This is now a null pointer. So it's a keyword that provides a type-safe pointer value representing an empty pointer. In older versions of C, C++ code, null was used for this purpose, the basic null, which was this. But null pointer is meant as a modern replacement. So this thing is now just a newer version. You could use both, but just try to use this one, as this might get deprecated soon. So that was it with this video. I hope you guys found this video useful. If you did, go hit the like button, and if you didn't like this video, go hit the dislike button and tell me why in the comment section. So that's it with this video, and we'll see you guys next time.